Storm Chaser Gabe Garfield, and today's date is March the 12th, 2024, and I'm going to be giving a small weather briefing about tomorrow's severe weather threat in the plains. So let's get right to it. Here in the day two convective outlook, as you can see, the risk has been assessed at slight, primarily over northeastern Kansas, northwest Missouri, and southeastern Nebraska. And the threat in terms of hazards is primarily a hail threat with a 15% hatched in that same area, which means that there's a higher probability of 2 inch or greater hail. And then you have a wind threat in the same area and a tornado threat of 5% there. And then extends down as a 2% down into southern Oklahoma. And so we'll start our forecast at 250 millibars. So this is at jet stream level. And this is from the GFS, a midday run, 18Z, today on March the 12th. And you'll notice, first of all, that you see split flow across the United States. Very strong southern jet stream across northern Mexico into southern Texas and along the Gulf Coast states. This is pretty commonly associated with El Nino, which is ongoing right now, and that is expected to abate somewhat towards the end of the season, but for the moment, it is dominating. And then, as you can see, with time, a trough enters to the west, and to the east, the ridge begins to develop, which is a pretty favorable pattern, as you know, for storms in the southern plains. And then that trough kind of enters into the plains right around midday, 18Z, about 1 p.m. on Wednesday, which is tomorrow. And then by peak heating, it is essentially over the plains and then kind of moves into the northeast Kansas area by 0Z or 7 p.m. Central Daylight Time. And so, really, the primary things I'd notice about this are really the development of pretty good curvature in the flow aloft. And you can see, nice trough out west, nice ridge out east. And so, in terms of curvature divergence, you'd expect pretty good idiostrophic curvature divergence aloft, which is typically associated with rising motion or divergence at the highest levels over, say, eastern Kansas into western Missouri. So basically, at the inflection point where you change from the troughiness out west to the ridge out east, you're going to get some rising motion there. And if you have any questions about this, please let me know, and definitely take a look at the advanced meteorology video that I just recorded. That will help you to understand that piece a little bit better. And the next piece is, I also noticed at the same time we do see a pretty strong jet streak moving in at 250 millibars. So you can see here winds greater than 110 knots in eastern New Mexico. So very strong jet streak aloft. And we can use our four quadrant model to understand where the rising motion with this particular jet streak might be. So if you divide it down the center, kind of from northwest to southeast, and then kind of along the jet axis through here, this would be the left exit region out to the front, the right exit region here, right rear entrance region, and the left entrance region right here. So the areas of divergence are left exit and right rear. And so basically, you would expect that the highest rising motion would be out in the left exit region here, which will be important for tomorrow. You'll notice that this region right here in Oklahoma, which is also under the gun, will primarily be in an area typified by convergence aloft, which would lead to sinking motion, which might act against the development of severe thunderstorms and possibly tornadoes, even though, as we'll see later, the environment in terms of shear instability is quite good down there. So we're moving down to 500 millibars. And the thing that we're going to be looking for here is vorticity, since vorticity will help us to understand where rising motion might occur, particularly through differential positive vorticity advection, which is another topic we covered in the advanced video. And let's go right to vorticity, actually, and let's see where these vort lobes come through. So this is 18Z today on Tuesday. So you can see that there is a vorticity maximum over the plains, or was a vorticity maximum over the plains, and that has moved to the east. And with time, you can see a developing vorticity lobe over the southwest United States, and then really it doesn't enter the plains yet at peak heating. So this is 21Z on Wednesday. So that is right around peak heating. And you can see that most of the vorticity is relegated to the areas north of the Kansas Oklahoma border. So, in terms of winds pulling that uh, vorticity to the northeast, basically advection winds moving that vorticity, that's going to be mostly over Kansas. And so that would be where you'd expect a rising motion. And that really comes in, those vorticity lobes come in pretty strongly by the after dark period on Wednesday. So there might be some storms developing after dark, but that will be also competing with the end of peak heating. So anyone's guess as to whether that stronger forcing will be arriving in time for severe thunderstorms, particularly down the dry line. I think for Northeast Kansas, it seems quite likely that these upper level forcing factors will lead to the development of storms in this area. Down the dry line, it seems like the dry line circulation will be really needing to be watched closely. And then you'll also be wanting to look for moisture and what that looks like. And so we'll kind of go down the line to 700 millibars. And at 700 millibars, we see pretty strong winds right now. And uh, I think most of the strongest winds are actually over Oklahoma. So there's a little bit better environment, I think, kinematically for shear and so forth in this area as compared to up in northeast Kansas, but we do and we will see some capping issues down to the south in terms of vorticity to see if there's any sort of vorticity lobes coming through that could potentially initiate convection. Don't see a whole lot in Oklahoma, although you move up to Kansas again, you see quite a bit of vorticity advection likely occurring as these inferred southwest winds push the vorticity on into northeast Kansas. And then moving down to 850 millibars, we can see that at 21Z, the winds are actually quite strong for late in the afternoon, 30 knots. That's actually pretty decent for peak heating. Usually the winds are not quite so strong as the air gets kind of mixed during the middle of the day, and then the winds kind of pick up towards sunset. But here we see reasonably strong winds, and that really picks up after dark as you see winds a little bit more in the upper 30 to lower 40 knot range and get to be the strongest really over Oklahoma. This is actually a pretty good low level jet. The one thing I do worry about is the orientation of that, which is mostly south southwest and north northeast, or even southwest and northeast, which would tend to imply a little bit more warm air advection at this level from the southwest. And if you actually look at temperature, you can see that there's a kind of a warm pocket there. So that would be a little bit concerning from a capping perspective. It's not quite so warm up to the northeast, which is why I think this area will be a little bit more likely to see convection. And then let's see, let's move down to the surface. And at the surface, the dew point temperature looks like it's going to be, at least according to the GFS, and let's go to 0Z. It looks like this pushes the dry line pretty far east to east of 35 with dew point temperatures in the lower 60s in Oklahoma, and then maybe even mid 60s as you head towards the Red River. And then way up into the northeast Kansas area, dew points are going to be primarily in the upper 50s, maybe mid 50s in the wraparound region. So not particularly high moisture, but because the instability profile is a little bit better out that way, it's not so bad. Let's look at a sounding here to see what that looks like. So this first sounding from northeast Kansas looks like pretty good shear profile. In fact, a very good shear profile. You have winds at the surface from east southeast. They veer to southwest aloft. Just a classic supercell and tornado profile here. This is exactly the sort of thing you'd want to see for tornadoes. And in fact, if you look at your 0 to 1 kilometer helicity, it's 172 meters squared per second squared. That's pretty reasonable. And then I assume that your deep layer shear is pretty strong. Yeah, 48 knots, pretty strong. Now your problem is definitely going to be thermo with this. Now this is of course from the NAM, or excuse me, from the GFS, which is not so great for this at this range. So probably would be more interested in looking at the NAM. In fact, let's go ahead and do that. So if you go over to the NAM and look at that, you see the moisture is a little bit better with the NAM, which is a sort of a shorter term model than the GFS. So GFS goes out to like 10 days. NAM only goes out about 3 days. So let's look for the same area in northeast Kansas. Let's see how that compares in terms of soundings. And this one has about the same profile, which is not surprising. The kinematic profile looks great. And then in terms of thermodynamics, looks a little better, except for there's a bit more of a cap here than there was in the other profile. So let's see. Further south into Oklahoma, maybe we can take a nice representative sounding from central Oklahoma. So it looks like the dry line is a little bit further west than 35 at this point, and you can see here very little cape. So, ooh, that's kind of ugly. Big warm nose there. So that's not what you want to see. You'd like to see that a little bit cooler. Like I said about those 850s, definitely not looking so great there in terms of warmer area advection coming in and bringing that nose a little bit further to the right. Meanwhile, the moisture here is not so great. 60 dew point probably won't cut it with this sounding. So that's why the potential hazard type is none here. Not so great. But we'll see how that turns out. I think this is probably a good time to get into the href here. Okay, let's go ahead and dig into the ensemble. So this is the href, which is an ensemble forecast viewer from the Storm Prediction Center. And basically this shows 10 model runs that were done separately that were kind of combined together so that we could get a better answer, or potentially better answer of what might happen tomorrow. And you can see here that this is looking at surface-based CAPE, the ensemble min. So at a bare minimum, we're going to be seeing, it looks like, maybe make this a little less zoomed in. It looks like we'll be seeing at least up to 500 joules per kilogram of CAPE along the dry line at bare minimum. In terms of average, you're expecting to see more along the lines of 1,000 to maybe even 1,500 joules per kilogram, so moderate instability. And then from a standpoint of max, the max values among the members look like about 2,000 joules per kilogram. And you can see as you kind of go from min to mean to max that it shifts to the west. And I think that's no coincidence. I believe that's likely associated with the prediction of better moisture return with the higher ensemble members. Now, another thing I wanted to get into was cloud covers. So let's try to find that piece. And you can see here that the cloud cover, and by the way, this is from the href on 312, that's today at 12 UTC, which is 7 a.m. So this is a little bit old. The new data is coming in, but it's a little bit late for me to cover here. But you can see that tomorrow afternoon, this is 5 p.m. Central Daylight Time, 6 p.m., 7 p.m. You can see quite a bit of cloudiness. Actually, going backwards in time, you can see um, quite a bit of low-level clouds being predicted here, and that's what you see in the blue is the low-level clouds, and then the high-level clouds, mid-level and high-level clouds are in the green and the red. So you get the picture. Really, there are going to be a lot of clouds, particularly from mid-morning to about late afternoon, and that kind of clears out in time for, I assume, peak heating. But that may limit the degree to which the surface temperatures can warm. So that may be something to pay attention to is the cloud cover tomorrow and its impact on the instability. So the next thing I wanted to look at was deep layer shear with CAPE and updraft helicity markers from the ensemble. And as you go forward in time from 2 p.m. to 3 p.m., 4, 5, 6, 7, you start to see these updraft helicity markers here in these little um, dark contours begin to form over northern Kansas and southern Nebraska and into western Missouri. So this would represent, I think, the greatest chance of convective initiation um, tomorrow afternoon and evening. And then as time goes on, you kind of see that, particularly as you get towards 0 and even 2 UTC, which would be 7 to 9 p.m., you start to see those fill in. So more coverage indicated by the ensemble here and towards the mid to late evening. And so I'm not sure exactly whether the surface parcels can remain buoyant enough to where they can take advantage of the shear that will be around and maybe some supercells. I suspect that a lot of this activity will remain elevated. I do think it's a little bit curious that one of the ensemble members has a parent supercell streak over southeast Kansas. So we'll see if that ends up panning out. The last thing I wanted to show you was the threshold probabilities for significant tornado parameter. And for those of you who don't know, the significant tornado parameter really is a combination of different things like deep layer shear, CAPE, low level shear, LCL, and it's really intended to give you a composite of all of the parameters that are most important for tornadoes. A level above one generally indicates that you have a higher chance of a significant tornado. Less than one is basically saying that if you do get a supercell, it is likely to be non-tornadic. And when you put that into motion here and you get towards the time of interest, you can see that generally speaking across the plains, pretty good probability by 7 p.m. Let me zoom in here. This is 7 p.m. You can see that higher than 70% chance that you'll see a significant tornado parameter above one across most of the plains, so that it would indicate an environment favorable for tornadoes across most of the plains. And then if you look at it in terms of significant tornado parameter above three, so that'd be a pretty strong tornado environment. The probability is obviously substantially lower, but there is some chance of that happening with an environment being most likely to develop of that nature in Kansas, but some chance along the dry line as well. So with that, I think I'll leave it there. If you have any thoughts, feel free to leave it in the comments and I'll be happy to respond there. Otherwise, if you haven't already, please like and subscribe. Thank you very much.